Hey everyone, in this video we will try to understand what are trigonometrical identities and how to prove trigonometrical identities. Any identity that has trigonometric ratio is called trigonometrical identity. So we have to learn three identities. Those three identities are sin square theta plus cos square theta equals 1. 1 plus tan square theta equals secant square theta. 1 plus cot square theta equals cosecant square theta. We can use these identities and manipulate them, that is shifting some terms from left hand side to right hand side and right hand side to left hand side, modify and use however we want. So there will be a statement given to you, an identity given to you, trigonometrical identity given to you, you just have to prove. In order to prove identities, what are the things that you have to do? What are the do's and what are the don'ts? That we will try to see first. What you can do is you can start from any side, LHS or RHS. Say you're starting from LHS. If you start from LHS, keep on manipulating LHS so that you reach RHS. Or if you start with RHS, keep on manipulating RHS so that you reach LHS. Or you can start with LHS and RHS separately and reach a same stage. And what you cannot do is you cannot shift terms from left hand side to right hand side. Let us take an example to understand this.
Say we have a question like this. Prove that 1 minus sin square theta times secant square theta equals 1. So here LHS is 1 minus sin square theta times secant square theta and RHS is 1. So let's start with LHS and I will manipulate this LHS so that I will reach RHS, that is 1. So LHS is 1 minus sin square theta times secant square theta. So just write only LHS. So we have three identities. Out of that, the first one is sin square theta plus cos square theta equals 1. But I have 1 minus sin square theta here. So in order to get 1 minus sin square theta, I will shift sin square theta to the right hand side. In that case, I get 1 minus sin square theta and that will be equal to cos square theta. So that means 1 minus sin square theta is nothing but cos square theta. So can I replace 1 minus sin square theta by cos square theta? So let me write cos square theta in place of 1 minus sin square theta. And I will write secant square theta as it is in this step. But if I look at these two ratios, that is I have cos theta and secant theta. Cos theta and secant theta are reciprocal to each other. Cos theta is adjacent by hypotenuse and secant theta is hypotenuse by adjacent by their definitions. So if I use reciprocal relation, secant theta is 1 divided by cos theta. Therefore, I can write secant square theta as 1 divided by cos square theta, or you can write cos square theta as 1 divided by secant square theta also. So cos square theta into 1 divided by cos square theta, I will cancel cos square theta and cos square theta. This will be equal to 1. So if you observe what I have done, I have started with LHS, kept on manipulating using some identities, and finally I have reached a stage which is equal to 1. So this stage or this number is exactly equal to RHS. So I had started with LHS and reached RHS now, and hence I can say that I have proved this identity 1 minus sin square theta times secant square theta equals 1. Hence proved.